Your textbook lied to you. The solar system doesn't end at Neptune. Past it, billions of frozen worlds are doing things that break physics right now. One's literally alive, and the whole region's hiding a planet nobody can find. Yeah, stick around. Okay, so real talk, you've been carrying a lie in your head since like 3rd grade. 8 planets, neat little row, Neptune at the end, and then just darkness. Credits roll, solar system over. And honestly, that version is so boring compared to what's actually out there that it feels almost criminal they taught it to us that way. Because what's actually sitting past Neptune, it's genuinely one of the most chaotic, rule-breaking, physics-destroying places in the entire solar system, and almost nobody talks about it. The region past Neptune is called the Kuiper Belt, and before we get into the individual objects losing their minds out there, you need to understand the sheer scale of this place, because it's honestly hard to wrap your head around. Picture a giant donut floating in space, flat and thick, sitting almost perfectly in line with all the planet orbits. That's the Kuiper Belt. It starts right at Neptune's orbit, about 30 times the Earth to Sun distance, and it stretches out to about 50 times that distance. So we're talking about a zone that begins 30 Earth to Sun distances away from us and just keeps going for another 20 on top of that. It's not a thin ring of rocks. It's a massive sprawling highway of frozen worlds extending billions of miles into the dark. And it's been sitting there quietly this whole time while we drew those tidy little textbook diagrams. Now you're probably picturing the asteroid belt, that the rocky band between Mars and Jupiter that movies always portray as this deadly gauntlet of flying rocks. Forget that comparison entirely, because the Kuiper Belt makes the asteroid belt look like a parking lot. It's roughly 20 times wider. It holds somewhere between 20 and 200 times more mass. And astronomers estimate there are over 100,000 objects out there that are larger than 100 kilometers across. The entire asteroid belt only has about 200 objects that size. So yeah, different league, different sport entirely, but what's all this stuff actually made of? Because this is where it gets really interesting. The objects out here aren't rocks, at least not mostly, because at this distance from the sun, it's so brutally cold that literally everything freezes solid. Water, ammonia, methane, all of it locked into objects as hard as granite. Astronomers call these volatiles, and here's the wild part. They've been frozen and unchanged for 4.5 billion years. The solar system formed 4.5 billion years ago, and the stuff sitting in the Kuiper Belt right now is basically the original leftover building material from day one, perfectly preserved in a deep freeze. You're not looking at a cosmic junkyard when you look at this region. You're looking at a time capsule from the literal birth of everything. Chapter 2, Arrokoth and how planets really formed. So how did it all end up out there? When the solar system was young, planet formation was an absolute mess. Think less elegant cosmic ballet, more construction site explosion. Building the giant planets left behind insane amounts of scrap material everywhere. Close to the sun, the heat was intense enough to vaporize all the ice, which is why the asteroid belt is mostly rock and metal, but out past Neptune, cold enough to preserve everything, and then Neptune itself, as it slowly drifted outward in the early solar system, basically acted like a gravitational snowplow, shoving debris further and further out until it all settled into the stable ring we see today. Neptune swept its room by pushing all the mess to the far end of the house, and it's been sitting there ever since. All right, so we've got the structure, we've got the composition, but what's actually going on inside this place? Because the Kuiper Belt isn't a graveyard of identical frozen rocks sitting there doing nothing. The objects inside it are some of the strangest things we've ever found anywhere in the solar system, and the first one we need to talk about literally answered one of the biggest unsolved questions in planetary science. In 2019, New Horizons flew past an object called Arrokoth, more than 4 billion miles from Earth. And before this flyby, the best telescopes we had could only see it as a single pixel of light. That's it, 1 pixel. Nobody had any idea what it actually looked like up close. When the images finally came back and scientists saw them for the first time, they stopped. Because Arrokoth isn't round. It looks like 2 flat red pancakes fused together. A big lobe and a small lobe connected by a narrow neck, like a squashed snowman that's been sitting in a dryer too long. And that bizarre shape ended a debate that had been running in planetary science for decades. For years, two competing theories existed about how planets form. One camp said it was violent, rocks crashing into each other at massive speeds, shattering and reforming until eventually something large built itself up from the chaos. The other camp said it was quiet, dust and pebbles gently clumping together in the dark over billions of years. Arrokoth settled it. If this thing had formed from a violent crash, the net connecting those two lobes would be smashed, cracked, completely wrecked. It's not. It's smooth and totally undamaged. These two objects didn't crash into each other. They drifted together over an enormous amount of time, slowly orbiting closer and closer until they gently touched and fused at roughly the speed of a person walking. A walking speed merger that preserved the exact recipe for how the solar system built itself. Planets didn't start with an explosion. They started with the slowest, most patient drift imaginable, and we had to fly 4 billion miles to find that out. Chapter 3, Haumea, the dwarf planet that should not spin like that. But not everything out here is this calm and gentle. Some objects in the Kuiper Belt are doing things that physically should not be happening, and the wildest example of that is Haumea. Haumea is a dwarf planet, roughly the size of Pluto, but it doesn't look anything like Pluto, and it doesn't behave like anything else we've ever found. It's not a sphere. It's shaped like a rugby ball, stretched out, flattened, more egg than planet, and the reason for that shape is completely unhinged. Haumea is spinning, fast, like embarrassingly fast. One full day on Haumea lasts less than 4 hours. Think about that. Earth's day is 24 hours. Haumea is doing 6 full rotations in that same time. The centrifugal force from that spin is physically yanking the equator outward, stretching the entire planet into that egg shape. If it spun even slightly faster, it'd probably tear itself apart entirely. Scientists think a massive ancient collision sent it flying into this violent rotation billions of years ago, and that same crash created its 2 moons and a ring system that circles it. One hit in the deep past, and Haumea has been spinning like this nonstop ever since. It's been doing this for longer than complex life has existed on Earth. It'll still be doing it long after Earth is gone. Okay, but if Haumea is wild, what Quaoar is pulling off is in a completely different category of strange. Quaoar is another dwarf planet about half the size of Pluto, and for years, astronomers considered it completely unremarkable, just another icy ball floating around. Then in 2023, they found a ring around it, and that's when things got weird. Rings are normally super easy to explain. There's this invisible boundary around every object in space called the Roche limit. Inside that line, a planet's gravity tears approaching moons apart, and their debris spreads into a ring. Outside that line, gravity pulls debris together until it builds a new moon. Inside equals rings, outside equals moons. Simple rule. Works everywhere. Except Quaoar is sitting there with its ring more than 2,500 miles out, about 7 times its own radius, which is way outside its Roche limit. By every model we have, that ring shouldn't exist. Those particles should have clumped into a moon decades ago, but they're just floating there, stable in a perfect loop, completely ignoring the physics we built to explain them. Some scientists think the particles are weirdly bouncy, colliding like rubber balls instead of sticking together. Others think a tiny hidden moon nearby is keeping them corralled. Nobody actually knows. Quaoar is just out there doing whatever it wants and offering absolutely zero explanation. Respect. Honestly. Now, both of those objects are genuinely strange, but there's a world in the Kuiper Belt that hits different from either of them because it doesn't just break a rule about rings or rotation. It destroys the entire assumption that frozen distant worlds are dead. Meet Eris. When astronomers found it in 2005, it triggered a full-blown crisis in planetary science because it initially looked like it might be bigger than Pluto, and that single discovery is the direct reason Pluto lost its planet status. We now know Pluto's slightly larger in diameter, but Eris is significantly more massive, and in every other way, it's more extreme. It orbits about 6 billion miles from the sun, roughly 3 times further out than Pluto. At that distance, the sun doesn't look like a sun. It looks like a bright star. Temperatures near Eris sit close to absolute zero, and for a long time, scientists were confident it was completely dead, a frozen block of ice that hadn't changed in billions of years. That assumption made total sense. Then Webb looked at it and flipped the whole narrative. Webb analyzed the light reflecting off Eris to figure out what its surface is actually made of, and it found fresh methane ice. Now here's why that matters so much. There are 2 types of methane. Primordial methane has been sitting there unchanged since the solar system formed. Fresh methane got produced recently by active geological processes happening right now inside the object. The methane on Eris is fresh. On a world sitting billions of miles from any real heat source, something inside it is still actively creating new material and pushing it out to the surface. Something inside Eris is alive. Here's how it works. Eris probably has a rocky core packed with radioactive elements, and as those elements decay over billions of years, they release heat. That heat slowly melts the internal ice, building up a layer of slush beneath the frozen crust. Eventually, the pressure vents outward, leaking gas and fluid that instantly freezes the moment it hits the surface. This keeps coating Eris in fresh white ice continuously, which is why it reflects nearly all the light that hits it, making it one of the most reflective objects in the entire solar system. It's not a fossil sitting frozen since the beginning of time. It's a geologically active world quietly churning on radioactive heat billions of miles from anything in complete darkness. We almost wrote it off as a boring ball of ice. Webb caught it mid-heartbeat, so if Eris isn't dead, what else have we been completely wrong about out here? Turns out we've been wrong about the Kuiper Belt itself because it's way bigger than anyone thought, and the way we figured that out is genuinely a wild story. For decades, astronomers noticed a pattern. Objects in the belt were everywhere from Neptune's orbit out to about 50 astronomical units, and then at that point they just stopped, dropped to almost zero, like someone drew a hard wall across space. They called it the Kuiper Cliff, assumed the solar system ended there, and that was that. Nothing but empty space until the Oort cloud thousands of times further away. Seemed like a reasonable conclusion. Turned out to be completely wrong. New Horizons is currently traveling through that supposedly empty region right now, and it carries a dust counter that logs every tiny particle it runs into. If space beyond 50 astronomical units were truly empty, those counts should have dropped to near zero. Instead, they kept coming in. Something out there was generating debris. The problem was it was too dark and too distant for any existing telescope to resolve until the Subaru telescope in Hawaii used a new deep imaging technique to stare further into the outer dark than we ever had before. In late 2024 and 2025, astronomers announced they'd found a whole new population of objects orbiting between 70 and 90 astronomical units. There isn't just one Kuiper Belt. There's almost certainly a second one with a massive gap of near emptiness sitting between them, and this structure of a belt, then a gap, then another belt. We see it around other stars all the time when we look at their debris disks. We just never realized our own solar system was doing the exact same thing. We were standing inside the first ring this whole time, assuming it was the only ring, while a second one sat quietly in the dark billions of miles further out. We missed it for decades. But even with a second belt in the picture, the math still doesn't fully work. The orbits of the most distant objects out here are all weirdly aligned, all getting pulled in the same direction at the same time. And a second ring of debris isn't heavy enough to do that. Something else is pulling on them, something we haven't found yet. This is where Sedna comes in. Discovered in 2003, Sedna is a large red world roughly half the size of Pluto, traveling in a massive stretched oval orbit that takes about 11,400 years to complete one single trip around the sun. At its furthest point, it reaches nearly 900 astronomical units from the sun, deep into total darkness. But the number that really matters here is where it gets closest. Sedna never comes closer than 76 astronomical units. That's the smoking gun. Objects in the Kuiper Belt are normally controlled by Neptune's gravity. Get too close, Neptune kicks you into a scattered orbit, but Sedna never gets close enough to Neptune for that to happen, and it's not far enough out to be pulled by other stars or the galaxy's own gravity either. It's sitting in this zone astronomers call detached, past Neptune's reach, but not yet in the galaxy's grip, no man's land. Sedna couldn't have formed in that location. There isn't enough material that far out to build something that size, and Neptune couldn't have scattered it there because Sedna never approaches Neptune closely enough for that interaction. Something else put it there, but what? Then astronomers started finding more objects with the exact same detached, stretched orbit situation, including one they literally nicknamed the Goblin. And when you plot all of them on a map together, the pattern is impossible to explain away. If they were just random scattered rocks, their orbits would be pointing in all different directions around the sun. They're not. Sedna, the Goblin, and several other extreme outer objects are all clustered together, their orbits all swinging out into space in the same direction, tilted at similar angles. The statistical odds of that happening by random chance are less than 1 in 10,000. That's not a coincidence. That's a signature. Something is hurting them. Only gravity can move objects at that scale and distance, and to have enough gravitational pull to control worlds this far out, you need something enormous. The math points to a planet between 5 and 10 times the mass of Earth, probably a super Earth made of gas and ice, sitting hundreds of times further from the sun than we are. At that distance, it'd be almost invisible, barely reflecting any light, moving so slowly it'd look like a fixed star. Astronomers call it Planet 9. We haven't seen it directly, not yet, but its gravitational fingerprint is all over the most distant objects in the solar system, and right now, it's the only explanation that actually fits everything we're seeing, and while all of that is happening, the individual objects in the belt keep getting weirder the closer we look. A binary system called Algira, sitting about 45 astronomical units out, got studied for nearly 2 decades and looked like a perfectly normal pair of icy objects orbiting each other. Then 17 years of Hubble data revealed tiny orbital deviations, shifts that only make sense if a third hidden body is secretly present. It's a triple, not a binary, and New Horizons stumbled onto something similar while flying past an object called Dinky Nesh, where what looked like a single companion moon turned out to be 2 separate objects that had already fused into one. These contact binaries keep showing up everywhere out here, and together with the hidden triple systems, they're pointing to something big about how the belt actually formed. The old assumption was violent collisions everywhere, but the evidence keeps pointing towards something much quieter. Most of these objects probably pulled themselves together slowly through gravity alone. No major crashes required. The Kuiper Belt isn't a record of ancient violence. It's a record of billions of years of patience. So let's land this thing. You were told the solar system ends at Neptune. It doesn't even come close to ending there. Past Neptune is a region with more objects, more mass, more complexity, and more active mystery than the entire inner solar system combined. It's got a fossil that solved a 50-year debate about how planets are born. It's got a world spinning so fast, it's physically tearing its own shape apart. It's got a ring sitting exactly where no ring is supposed to be able to survive. It's got a geologically alive world running on radioactive heat in total darkness. It's got a whole second belt we literally just discovered. And somewhere deep in the outer dark, invisible and enormous, it's hiding an entire planet we've never directly seen. The Kuiper Belt isn't where the solar system ends. It's where everything we thought we knew about it falls apart. And every single time we think we finally mapped the edge turns out to be somewhere further out than we thought, hiding something stranger than we expected. Next time you look up at a clear sky, remember the most interesting stuff isn't what you can see. It's what's out there past everything you can see, quietly breaking physics in the dark, waiting for someone to finally look close enough. And if you learned a lot from this video, make sure to hit that subscribe button for more space content like this.